Let's have a look at cables. This is a typical single phase 32 amp charging cable. It's TUV approved or certified. It's got 3 by 6 millimeter live earth and ground wires, as well as 2 by 0.5 millimeter control wires. Now, looking inside, you can see how those wires are placed. The main current wires are in the middle. The two the two control pilot wires are on the side. Most cables only have one pilot, but our generation 2.1 cables have a redundancy built in by having 2 wires. These control the signal between the car and the charger, and they're critical to the operation of the charging process. So we'll see what happens when we have an actual control cable, which is this wire. It was taken from the inside of one of these wires, and you'll see I've attached it one end with the sticky tape, and the other end I've left free. Watch what happens when we bend it, and it's on the outside. You can see here that wire is now deformed about 1 centimeter, and if I hold that end, you can see how far it's had to move to accommodate that 90-degree bend. Of course, when it's inside, that movement won't be nearly as much as 1 centimeter, but it would probably be in the order of half of that, so half centimeter. So of course, when you're dealing with a 0.5 millimeter copper wire, even a half centimeter stretch will be sufficient to break it. So anything more than 90 degrees like this will break the CP wire if it happens to be on the outside. If it happens to be on that in the middle, on either side, then it's okay. You can get away with it. If it's at the bottom, it will compress it and cause stress fractures. So the best thing to do is not to actually bend it too much, and that's the cause of CP breakages that we've experienced.